Hello, my name is Omar Nasir, and this is my presentation for an iterator design pattern. So let's begin. So the intent of the iterator design pattern, the intent will be to provide a way to access the elements of an aggregate object sequentially, basically moving forward through each element within the collection of data. The other intent is to access each element without having to know the exact details of the data structure. You'll be able to iterate through any form of collection by creating a general purpose GUI. You're able to make changes to an actual collection without making changes outside the collection. This abstraction is provided by the iterator pattern. So basically the general purpose, the intent of the iterator pattern, basically you'll be provided with a collection of data, whether it's a list, whether it's a vector, and the whole purpose of the iterator pattern is to be able to iterate through each element within the collection of data without compromising the data structure. You'll be able to know what current position, what's the next position. It makes it very simple to iterate through that collection of data, through that data structure. So the motivation here, we all deal with data structures of a collection. Could be anything from a list to a vector and so on. We all had an array and wanted to iterate each element in their container. So basically the general motivation of this is to provide a way to what I exactly explained earlier about the intent about the container and be able to iterate through it. The way the data is represented will not matter because it will iterate through every element in the container. Iterator pattern has a job to access through all the objects of the collection and put it in the iterator object that holds the position in the collection. It keeps track of the current item and it identifies what items will be next in the container so it can iterate through it. So here we have the key participant basically when it comes to the iterator design pattern. So we'll start off here with the iterator. Basically the iterator, this defines the interface that's going to traverse through the collection of the elements. So the iterator, the whole purpose of it is it's in the name. The iterator is going to actually iterate through every element within the collection. Now you have the aggregate. So the aggregate defines the interface that's going to hold the collection of iterators. So the aggregate is going to have a collection of iterators that shift through that collection, and basically it's going to hold all of that. The concrete iterator, basically the concrete iterator implements the iterator interface. So it's going to know what current position is when it's while moving through all the elements. The concrete iterator is going to know its current position, so when it's moving through every other element, it knows what's next. Concrete aggregate, this will implement the aggregate to return an instance of the current or next position in the concrete iterator. So the structure here, so basically you have, like as I explained, you have the aggregate, the iterator, concrete aggregate, and the concrete iterator. So the concrete aggregate implements the aggregate class, while the concrete iterator implements the iterator class. So the aggregate class basically creates the iterator, and then it's going to be implemented by the concrete aggregate. Here we're going to have the concrete iterator, and that's going to implement the actual iterator, which will show you where it's starting, what's next, when it's going to be done, and the current item. So the consequences. The consequence of the iterator pattern is that updating a container is very hard to do. If updating is needed, it's going to be difficult. When we have a very complicated data structure like hash tables, yes, it's going to be able to iterate through it, but it's going to be a challenge just to maintain it. Another consequence is that you can only use one data structure at a time. So whether it's an array or a vector or whatever you decide to use, you can only use one at a time. You can't use multiple ones when you're using a design pattern. So the known uses. So the main uses of the iterator pattern is that it is mainly used in an object-oriented system. Usually most collection class libraries offer iterators in some form so that's easier to use. So having that collection can be iterated through when compromising the structure itself is a great tool to have. So, in general, the iterator design pattern is just it's a nice tool to have. It's a nice skill to have. I mean, we all dealt with vectors, we all dealt with arrays, and all these different types of data structures that hold a collection of elements, a collection of data. And being able to hold a collection of data, and whether it's it's you have like grades, you have grades for students, you want to iterate through every grade and every name, and you need a way to do that without actually compromising the data structure itself. The design pattern is a great tool to have, but I feel like it's something a lot of people would have, would make it easier to use when dealing with these kind of data structures. So here's all my works cited, paid, basically all the resources I used to um, get all the information and data. So now let's get to the code. So we'll start here with the iterator class. So basically it has the next, iterates through the next one and so forth. Now we have the container. Basically the container is or the holder, I'm sorry. It's a container that basically gets the iterator. As I said earlier, it's going to be implemented by this. Basically, name this basically just names the actual I'm sorry, implements the holder interface. This is basically our concrete aggregate. Hold all the names, but iterates through every name, returns it. And then here is actually our main where everything is being implemented. So for iterator, if it has next, then set it and then print it out plus the name. Basically iterate from start to finish. So here, well, I already ran it, but basically when it iterates, it's gonna start from here, iterate through each one. So Tommy, then Jordan, and then Kobe, and then Magic. It's gonna iterate through each element in this container, and then I just outputted it, made it very simple. Another thing what's neat to do is what we can do is, like I said, we can always edit it. So oh, excuse me, we'll keep the professor's name first. We can always edit it, always edit it here, edit name, if add, whatever many names. I guess we can just add one here just to show. And then we can run it. And then here, see, so I didn't have Omar here. So once I edited it, I updated it, and now iterated, iterate through it and printed out each element within the container. Made it very simple to use. So in general, guys, just the general purpose of the design pattern, as I said before, like I said, for this instance, you have a collection of data, and in this case names, and it's just a way for it to iterate through each element within this collection easier without compromising anything else. Thank you so much for your time, and have a great day, have a great night. Thank you so much.